Today's notes are going to be on the next two shortcuts here in Module 5, Lesson 4, ASA and AAS. And so the first one is ASA. Remember, these are congruence theorems, so you might want to say ASA congruence. And that stands for angle, side, angle. And so if it was my notes, I would probably, just write down angle, side, angle, or ASA congruence and draw the picture. Right? And so why is it angle, side, angle? Well, it's obviously, if you look at the two triangles, I have these two angles congruent to these two angles, and the side that's included, which means it's the side that's between them. And so if you were to name it in order, you go from this angle to that side to that angle. Usually in class, I have somebody ask about why can't I go around this way and go angle, angle, side. And when you're naming these things, you can't skip more than one. You can't skip two in a row. So if I go around this way, I'm skipping this side, and then I'm skipping this angle, and I can't skip two in a row. So I can't go that way to name it. I have to go this way to name it. So angle, side, angle. And then the next one here is angle, angle, side congruence. Now I want to put a side note in here that this could also be SAA. Right? It doesn't matter which order you put the letters. So angle, angle, side, and side, angle, angle are the same thing. Why do we usually call it angle, angle, side? Because some mathematician long ago decided that. Again, if it was my notes, I would put angle, angle, side congruence, and I would put the picture down here for myself. Again, two angles in one triangle, congruent to two angles in another triangle, and one side. But in this case, it's not the side in between them. So it's one of the other sides. So it goes angle, angle, side. All right, if I went around this way, could it be angle, side, angle? No, because it can't skip two in a row. And if I go around this way, it's angle, skip a side, skip an angle, cannot skip two in a row. So I have to go around this way or that way. And so I would get angle, angle, side, or side, angle, angle. Let's look at, before we look at examples, let's just kind of summatively review. The other day we had side, side, side congruence and side, angle, side congruence. We also today added angle, side, angle, and we added angle, angle, side. And so what is missing? Well, we talked about when we did side, 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 the angle, angle, angle does not work. All right. So angle, 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 it doesn't work. What other combinations of letters do we have? Well, we could have side, side, angle, or angle, side, side. Those are kind of the same thing, just like this is kind of side, angle, angle here. And it would be funny maybe if that worked, but it does not, unfortunately. And so I usually say AAA batteries, great to charge your stuff, or AAA auto insurance, great for your car, not good for geometry. Swearing would be hilarious. Angle, side, side is funny, but not effective. Right. So now when I go to write a proof, hopefully you know by now the first step in the proof is to write the given. So angle BAC is congruent to angle DEC, and segment BD bisects segment AE. And that was all given. And now, do you understand what the given says? And if so, mark it. So angle BAC is congruent to angle DEC. BAC is this angle up here. They already put a little mark there. I'm just going to draw it a little bit bigger and better. It's congruent to angle DEC. So this angle here, they already put a mark there. I'm just going to draw it a little bit bigger and better. So those little marks mean the angles are congruent. Segment BD bisects segment AE. It's important you can tell from the way it's written what is getting bisected. And so AE, segment AE is getting bisected. So segment AE is getting split up into 2 equal parts. And so when I name those parts, the first part goes from A to C, and then it goes from C to E, or you could have said EC, and that was because you knew what bisect meant, definition of bisect. And then last but not least, sometimes in these proofs, there's things you just have to see for yourself. And so they're going to expect that at this point, when you see crisscross lines, you understand vertical angles are congruent. And so that would be angle ACB is congruent to angle DCE because of vertical angles, or vertical angle theorem. And then last but not least, is that enough to say the triangles are congruent? And the triangle on the left, I have an angle, side, and an angle that is congruent to an angle, side, and an angle in the triangle on the right. And so triangles ACB and ECD are congruent by angle, side, angle, which is what we were trying to prove. So your proof is always going to start with your given, end with your proof. But we don't write prove down here. It's always the reason, which for us in this unit is basically one of the shortcuts. All right, one more example to look at here. Again, I start every proof with the given. So RQ is congruent to ST. And then hopefully you recognize this other symbol. RQ is parallel to ST. Again, anytime I say something in the given, I want to mark it. And so they already have, but I want to mark it as well. So the lines mean they're congruent, and the arrows mean they're parallel. Now, how does that help me? How does it tell me that it's parallel? How is that beneficial? And what they expect is that you know if lines are parallel, that alternate interior angles are congruent. So angle R would be congruent to angle T because they are alternate interior angles, which is the alternate interior angle theorem. Now, you could also say angles S and Q are alternate interior angles. All right. I'm going to pretend like I missed that. I saw this parallel and I thought, okay, let's look at the angles. I see a pair of alternate interior angles. All right. And so instead of saying S and Q, I want to see the vertical angles inside here. And so I'm going to say, hey, this U on the left is congruent to U on the right. And so I have to name them that way. Angle RUQ on the left is congruent to angle SUT on the right because they're vertical angles, which is the vertical angle theorem. And now do I have enough to say the triangles are congruent? And if you did it like I did it, then you would, and you would have triangle RUQ is congruent to triangle TUS, and that would be angle, angle, side. If you used the both sets of alternate interior, it could be the same thing, but angle, side, angle. So this proof has definitely more than one way that would work successfully. These are the ones we're doing in my class. I wish you the very best of luck. Contact me if you need more assistance.